This particular expression is considered a complex fraction. And the name kind of explains why, right? When you look at this thing, it's scary. It's like fractions on top of fractions. Okay, and then we've got like fractions being added. That's another fraction. So there's just like fractions everywhere. Okay, is how we can kind of think of these complex fractions. Now, really what we're going to work to do is with the complex fractions, we always want to have or set this up to where we have one rational expression. Okay, so we'll call this is a one, I'll abbreviate rational with rat expression. Okay, so that numerator is already one expression. And then we also want the same thing in our denominators. So we're always working to get our complex fraction to where it's one rational expression divided by another. Because if that's the case, this is just a division problem. But if you look at like number 2, the numerator is not one rational expression. It's two expressions being added together. So we would actually have to add them before we can do the next step in this. Okay, so this we like. This is always what we're trying to accomplish. Can we get one rational expression divided by another? Because if we can, this just turns into a division problem where we're going to copy, dot, flip. So this is really no difference than just us dividing fractions. Okay, so I'm going to take this first fraction, which is the entire numerator. I'm going to copy that down, x plus 4 divided by 5. Then this division is going to change to multiplication, and we multiply it by the reciprocal of the fraction that we're dividing by. So it becomes x squared over 25. Okay, and once we get here, now it's just simplifying this rational expression. Here where we've got some multiplying. I don't think we're going to get really anything to divide out here because I have x plus 4 times x squared divided by 5 times 25. So that's x squared times x plus 4 divided by 5 times 25. This actually is considered all the way simplified. But if you took it one step further and multiplied, we'd get this to be x cubed plus 4x squared over 75. And then there are still domain restrictions. Again, domain restrictions happens from any x value that causes us to divide by 0, and that division can happen anywhere. Okay, so really with my domain restriction, I'm looking at all pieces except for this entire numerator. Okay, so this x squared, if x is 0, we're dividing by 0, and that's a problem. Okay, with all the other pieces here being a number, we're not going to get a domain restriction from that. Yeah, Liam, what you got? 125. Thank you. I was doing 3 times 25. Okay, so that one was set up, ready for us to go. But if you look at like number 2, and then even down a little bit further, it's number 3, we're not set up ready to do the division yet. We need to combine the fractions in the numerator and the denominator before we can carry out the division. So here, we need to add the fractions first, or add the rat expressions first. So the adding is almost like its own separate problem. So we're building in just about every single thing that we worked on with simplifying the expressions. So I'm just going to take this numerator and I'm going to work on this on the side. And I'm going to find a way for how I can actually add these together. So I'm just going to copy that numerator off to the side. A 3a minus 5 plus 3a minus 5 over a squared. Okay, so you're also getting a review on how to add fractions right now. And right now, the denominators aren't even close to being the same. And remember that when we go to get a common denominator, we have to multiply by some form of 1. If we're not multiplying by 1, we're changing the value of this expression. Okay, so that idea of multiplying by 1 is really important here. Because there are no common factors in either denominator, this is going to be a case where I take this first fraction and multiply it by the other's denominator. So that's a squared over a squared. So my denominator is going to end up being a squared divided, or a squared times 3a minus 5. With the second fraction, I have the a squared, so that part's the same, but now I'm missing the 3a minus 5. So I'm going to multiply it by 3a minus 5 over 3a minus 5. All right, so when I do that, I get a squared times a, that's a cubed, plus, we'll save this 3a minus 5 times 3a minus 5. We'll do that in the next step. So that's me just taking these numerators and adding them together. And then it's all over the common denominator of a squared times 3a minus 5. Now this is where, like a lot of you on the quiz, you wanted to cancel out 3a minus 5s, and I get that temptation, right? It looks like everything's been factored. I see that 3a minus 5. It's the same as this one down here. We want to cancel. Okay, I absolutely get that. However, because we have 3a minus 5 times another 3a minus 5, but we're adding a cubed to all of that, it completely changes that these are 3a minus 5s. Okay, so we actually can't cancel yet. And that's where a lot of you were making mistakes when adding and subtracting the rational expressions. You're trying to cancel too early. Instead, we need to continue to simplify this numerator. So I'm going to FOIL the 3a minus 5 times 3a minus 5. That makes this a cubed plus 9a squared minus 15a minus another 15a and then plus 25. All over that denominator of a squared 3a minus 5. I have a couple like terms in these negative 15a's. So now this is a cubed plus 9a squared minus 30a plus 25 over a squared 3a minus 5. Yuck! All right, that was only to simplify the numerator. We still haven't even done the division yet. Okay, so now that, remember, really we just took the numerator and we took this off to the side. Now I'm going to bring this new numerator and replace it with where the two expressions were previously and just write what I currently have. Okay, so this is now turned into this whole fraction, so a cubed plus 9a squared minus 30a plus 25 over a squared and then 3a minus 5. All of that is now getting divided by 3a minus 5. So now we've set this up to where I have one rational expression. Okay, this is that one rational expression. The denominator is also a single expression. Some of you might be looking at that and you're like, wait, no, it's not. We're just dividing by 3a minus 5. Well, if I want to turn this into a fraction or an actual, I guess it's not technically rational because there's no variable in the denominator, but I can make this a fraction by putting it over 1. And now I can do the copy dot flip. So copy that entire numerator of a cubed plus 9a squared minus 30a plus 25 over that same denominator, a squared times 3a minus 5. Then we change division to multiplication, and we multiply by the reciprocal of that denominator. So I'm flipping that fraction, making it 1 over 3a minus 5. And the This one is really ugly. And so now this expression is a cubed plus 9a squared minus 30a plus 25 over a squared 3a minus 5 times another 3a minus 5. And I don't think anything cancels. That's about as far as we can go. Okay, in order for things to cancel, we would have to refactor the numerator, and that's not going to factor. Now we just need to think about domain restrictions. And with that, I just go back to my original. So the 3a minus 5, that shows up in two places where I could be dividing by that value. That gives me a restriction of 3a equaling 5, and thus a cannot equal 5/3. So a cannot equal 5/3. And then the other restriction comes from the a squared. Again, all I'm looking for are places that I might divide by 0. A squared, if I said that equals 0, I get that a cannot equal 0. So two values we have to exclude from that domain. All right, that one was pretty ugly. Okay, I'm going to see what you all can do with number 3. Okay, so why don't you try your very best, and let's just do this in pieces. Let's first have you adding the two rational expressions in your numerator. So can you get a common denominator and add these fractions together? Can you do the same thing with the denominator? Get a common denominator and add those together, and then we'll see where you're at from there. So let's take like 3 minutes to just add the fractions up top, add the fractions on bottom. And again, I'm just doing each of the adding and subtracting separately. I always call this doing side math, where I just take a part of a problem and work to simplify it on the side. Rather than just working with it in that whole expression, there becomes a lot more writing. So the numerator, one I did not choose. There probably is a smaller value I could have gotten as my common denominator. 30, 45. 45 would have been the smallest denominator you could have gotten there. So multiplying the 4/15 by 3/3 and the 2u over 9 by 5/5. I kind of took the approach as to what I would expect most of you to do, and that would be take the value of, or the denominator of the other fraction and multiply it by that. So this second fraction, 15/15, the first fraction multiplying by 9/9. Makes us 36 plus 30u over 135. Again, that can be simplified. I'm going to deal with the simplifying towards the end here. And then I have the bottom fractions. They already have a common denominator. Okay, so I don't need to multiply that at all. Okay, I just need to add the fractions. Come on, why does it keep getting out of focus? So that makes that u plus 2 over 3. So now the fraction with all common denominators is 36 plus 30u over 135 divided by u plus 2 divided by 3. I want you all to take it from there. Do the copy dot flip. See if there's any extra simplifying. You might have some GCFs towards the end that divide out. Let's see what we come up with. 2 more minutes for that, and then that's the last thing I got for us today. Can we get voices to stop, please? All right. So from here, this is about our checkpoint that we got to. Then I'm carrying out the division up over here. So copy that first fraction. I'm not changing anything about it. Multiplying by the reciprocal of that second fraction. Now, when I do that, there's lots of different ways of how I can eventually simplify this. And it does get a little confusing. And a lot of that is because I did not get the smallest denominator when I kind of first started with that top fraction. So there's a lot more GCF work that happens later on. So I distribute the 3. I distribute the 135. I'm actually going to undo that almost immediately. So distributing the 3 makes this 108 and then 90u. Distributing the 135 to the u plus 2 makes that 135u plus 270. In that numerator, I'm looking for the greatest common factor there, which is 18. So I can factor out an 18 from 108 and from 90. That makes that 18 times 6 plus 5u. The denominator, I'm just taking that 135 right back out, so I really didn't need to distribute it anyways. Then 18 divided by 135 reduces down to 2/15. That's what this, I wrote it down incorrectly the first time. Yeah, that's supposed to say 2/15. And remember that with some of those reducing down of fractions, like 18/135 is not super obvious. And so in my calculator, I did that division, 18 divided by 135, and I went math, enter, enter, and got it to be 2/15. Okay, that is a trick that I've shown us before. Okay. The rest of this assignment is your homework. You have 6 more to work through. And yeah, I'll give you the next 10 minutes to continue to work on this.